Hi everyone. Today we are going to discuss Hdlc or high level data link control. Now to understand Hdlc, let's suppose these are two users on the same network, and if this user wants to send some information to this user, and if they are on local area network and this network has been established by using Ethernet protocol, it means both of the users have Ethernet link between them. Then by following Ethernet protocol, they can actually exchange the information with each other. But for instance, if the second user is far away from that user, for instance, that user is in other country, then we need to have a wide area connection between them. And lease line wide area network link is one of the possibility to connect these two users. And the job of the lease line is to carry zeros and ones. So the job of the lease line is to provide the services of physical layer. And if you remember, the job of the physical layer is to carry the information blindly. It works as a water pipe. So the information just flows on the physical link. So from the perspective of TCP IP model, the user by using application layer generates some data, and by following rest of the layers, the data is handed over to the physical layer. And the job of the physical layer is to carry that data. But this physical layer doesn't have any information about the address, because this is only responsible to carry the data. It doesn't have information about the address or the errors in the frame, or it doesn't know the start and the stop of the frame. Even there is no concept of the frame, only the raw data in the form of zeros and ones travels through it. So for these all kinds of jobs, for example, the address, error checking, and start and stop bit, so that we know that where is the stop and where is the start and stop of the data or the frame, we need to have the services of data link layer. And so the job of the data link layer, the principal job of that is to deliver error-free messages to the intended destination. It means some of the error checking and some of the addressing mechanisms should be there. And for these lease line, Hdlc is the answer. So this is the reason we are going to study Hdlc today. Hdlc is a data link or layer 2 protocol, and this was defined by ISO. ISO is a standard body who gave us OSI networking model. So what happens when the users are far away and they want to exchange some information? Then for instance, this user wants to send some information to this user, and now from this user to this router there is an Ethernet link. So there is an Ethernet link, and by using this Ethernet protocol, this user generates a frame, and that frame actually travels from this user up to this interface of the router, and we receive an Ethernet frame. So you can see Ethernet header and Ethernet trailer means we have received Ethernet frame at this interface of router, and the router will decapsulate this frame. Decapsulate means it will remove the header and trailer from that frame. And now by looking at the IP address, this router has to forward that frame to this router. So there is a link. Which kind of link is there? This link is leased line WAN. This is not Ethernet, but this is the leased line WAN, and for that we need Hdlc data link layer protocol. Then this router will encapsulate that packet using Hdlc header and Hdlc trailer. So this is called Hdlc frame, and this Hdlc frame basically is transmitted from that router to the next router. Now once this router has received this frame, this will decapsulate that frame. It means this will remove the Hdlc header and Hdlc trailer from that, and now the connection from this router to this user, this may be Ethernet again, and this router has to encapsulate that packet with respect to Ethernet, and the user will receive that frame. Now we have to discuss that what is in this Hdlc header and Hdlc trailer, which is going to help us transmit our data using these lead lines. So first of all, we are going to discuss the Hdlc frame format given by ISO, that is known as standard Hdlc frame. In this standard Hdlc frame, we also have Hdlc header and Hdlc trailer, and we also have the data for sure. So packet carries the data, which has the actual information, and in the header part of the frame, we have this control field, address field, and the flag field. And in the trailer part, we have FCS. And these all fields are actually represented as zeros and ones. And these field has some information to convey with the help of these zeros and ones. First of all, the flag field. The flag field has some specific bit patterns indicating the arrival of new frame. This indicates the start and the stop of the frame. So you can see this specific bit pattern actually indicates something special. And then we have the address field. Address field shows the destination address where we want to send our data. So addressing, we have the address field, and then control field. Control field actually defines different formats, frame formats, so depending on the types of the frame. So we have different types of frame, and control field helps to define different formats. And then we also have this data field, just we discussed, which carries the network layer data. And then we also have this FCS. FCS is there to check for errors. That stands for frame check sequence, and that is used to detect errors during the transmission between nodes. For example, in our case, we had one router, we had second router, maybe R1 and R2. So when the frame travels from this router to this router, there may maybe some of the errors have been introduced in the frame. Then this router, by using this field, can check that if some of the errors have been introduced during the transmission. And if the frame has been corrupted, our frame has some of the errors, then this router can actually discard that frame and it will not process it. And if there are no errors, then this router can process it for further delivery to the next hop or to the destination. So this is the job of frame check sequence. And then we have a Cisco specific Hdlc frame. So in Cisco specific or Cisco proprietary Hdlc frame, we have all the fields which are given by ISO. For example, we have this flag field, we have the address, we have the control, we have the FCS, but we have an additional field that is called type field. And the job of the type field is that this defines the type of the packet encapsulated in the frame. So you see, this is complete a frame. This is a complete frame, but within this part, we have the network layer information. So we are carrying the data which is given to us by network layer, but which network layer protocol has given us this data? This is defined by the type field, and this type field is introduced by Cisco, and this is called Cisco Hdlc frame. So ISO standard Hdlc does not have a type field, but Cisco standard does have a type field in it. After discussing these Hdlc frames, let us discuss some of the characteristics of Hdlc protocol. First of the characteristics is that Hdlc is a bit-oriented protocol. It means the control information is carried by using bits. But in some of the protocols, they use bytes or characters. It means 8 bytes are used to convey the control information. But in Hdlc, bits are used to convey the control information. And Hdlc also supports point to point as well as point to multi-point. So this point to point means from this one point to another point, and but for point to multi-point means there can be multi-points there. So HDLC supports both the point to point as well as point to multi-point connections. And HDLC is a synchronous data link protocol. It means both the transmitter and receiver are synchronized by clock pulse. It means the transmitter and receiver know that where is the end or where is the stop, or when the data is starting and when the data is stopping. They are synchronized with each other by using some of the clock pulses. And finally, Cisco uses HDLC as the default encapsulation method for synchronous serial lines. So this was some overview of HDLC, and thank you very much for your time.